I want to talk about two main things. The first one is what is engineering, and the second one is what is CDIO. Now, again, I would like to start with the emotional intelligence, because I would like to connect, if possible, connect engineering to the emotional intelligence and how emotional intelligence is very important to have a successful engineering career. So as we remember, hopefully, that the cornerstone is the self-awareness. So you need to know yourself. And from that, once you know yourself, you'll be able to manage yourself. So self-management is how you control your emotions, how you portray yourself in the best possible way, how do you work with people, how do you convey your messages to them in a way that hopefully creates a behavioral change. And then you need to have the social awareness, in which you are aware of your impact on others, as well as awareness of how others feel, how others perceive the way you communicated with them, the product that you made for them, and things like that. Eventually, all this feeds into relationship management, which is something we agreed is extremely important for anyone to work in a team, to be a leader, to be a manager, and things like that. Why is this? Is this the Highland Tower? No, it's not. This building is in China. So can you imagine what has happened here? This building used to be standing like that. It actually collapsed. So are you with me? You understand why is this? Now, I just want to say something. Without engineering, please pay attention to what I'm going to say. Without engineering, this disaster would have never happened. Without engineering, we would have never had this disaster. Do you agree with me? Who agrees, raise your hand. Who disagrees, raise your hand. Who doesn't understand what I'm talking about, raise your hand. Okay. So what I'm saying, okay, there are many disasters that has happened, man-made disasters that has happened in this world. Challenger exploded, right? The space shuttle. We have bridges collapsing. We have buildings collapsing. We have airplane, crashing and failing because of engineering system failure. So can we say accurately, without engineering, we would not have these disasters? Anyone want to say something? Do you agree? Do you disagree? Who agrees? Raise your hand. Who disagrees? Raise your hand. Okay. Who did not raise the hand first time, second time? Raise your hand now. Who did not raise his or her hand in the first time or the second time? Please raise your hand now so I can engage you. Cannot be. Not everyone raise his hand. Okay. Who agrees? Stand up. Okay. Okay, you remain standing. Okay. Okay, please. Who disagrees? Raise your hand. So, Madi, what's happening? Madi and Medina. Or, okay. Okay, sit down. Okay, okay, put down. So, Mahdi, do you understand what I'm trying to say? Thank you. So now, please pay attention. I'm going to say it for one more time. Mahdi, do you understand this picture? Do you understand what's happened in this picture? Is this picture clear? Can you see it? Is it clear? Okay, so this picture is about
House.
building. Yes,
Building,
yes. Yes, building.
Building. Yes.
Collapse.
Ah, okay, okay.
This building
Ah, okay.
was like that. Collapse.
I understood. Yes.
Okay?
Okay.
Now, my statement is this. In this case, do you think there are some people die?
Yes.
Definitely. Many people injured because there are people there inside, right? Definitely there are people injured and probably people have died as well. So this is a disaster. This is very bad thing.
Yes.
Right?
Yes.
Now, what I'm saying, without engineering, if there was no engineering, we would not have this disaster. The engineers here made a mistake.
Yes.
And because of this, people die.
Yes.
Okay. So if there is no engineering, there will be no disaster like this. Is this correct? So I had few people who agree, many people who disagree. What do you think?
I think if you live without engineering people, we don't build this building.
Yes.
Yes.
Yeah, but you see, when we don't build this building,
Yes.
we don't fly, we don't go to the moon, then we
don't
also
anything,
won't die.
yes.
We won't have the crash, right? Okay. So those who did not agree, can someone tell me why you don't agree? Okay, give to. Okay, let's see what she's picking someone else. So okay, just give to Hans, and then Sugdish can say something later.
Why we disagree that if engineers, nothing will happen, right?
So I'm saying without this, without engineering, we would not have this disaster. Maybe, yeah. So you disagree?
Yes.
Why you disagree?
Because there will always be things that we cannot expect, and always there will be like different forces. Maybe the calculations will go wrong. Maybe the design will go wrong. Maybe even construction will
But
go
you see,
wrong.
there's no engineering in the first place. There is no design. There is no building in the first place.
Yeah.
There's no engineering, there's no building. Say the natural.
Natural disasters.
I cannot hear you.
Natural disasters.
So natural disaster could still happen.
Yes.
But you see, when a natural disaster happened in this case, where you have put so many people in, then the likelihood that more people will die with engineering is maybe higher. Maybe. Now, you want to still want to say something? Yeah. Yeah. Give Sugdish the opportunity, and then I'll make comments. You want to say something after? You agree to both. One second, let him say something, and then we listen to you. Yes.
I think it could be possible that the engineer who brought up this project did not follow the ethics of engineering.
Right.
So that's why this disaster happened.
Right. So this is not every engineer will not follow the ethics and the normal way of doing things. So maybe it would have happened in this case, but in other cases, so we cannot blame engineering as a whole. Okay. I think you want to say, yeah. Maybe you go that way. Yeah. So let's listen to one more, and then I will comment.
Without engineering, none of this disaster or havoc would ever happen, because none of these buildings will have ever constructed, and everything will be just flat on land, so there won't be any building stopper or any But with engineering, we can have all these buildings, we can enjoy all the privilege, the aircon, a comfortable home, but we cannot expect anything that will be perfect. So there are things that might happen once or twice, but you cannot take that as a negative thing, because look at all the things we have now, all the beautiful things that we
Yeah.
have. We have to look in a point of view that there's a positive effect on the things we do and a negative also.
Sure. Thank you. So what he has. So I just paraphrase. He said, yes, I agree. Without engineers, we won't be having planes to crash. We won't be having buildings to collapse. But also, we won't be able to travel. We won't be able to communicate the way we do. We won't be able to have iPads and aircons and all the successful things that we have had. And you are right. I fully agree with you. So we would have not have maybe the iPhone. So, but what is engineering actually? So what is engineering then? You want to try? What is engineering? That's a question. Maybe you speak it to the phone. Yes. Please listen.
I think engineering it is all of technology things.
Right.
I think yes, because without who says that we can live without engineering? We cannot live without engineering, because engineering it is, I think it is all of things in our world. For example, in engineering we have physics classes, yes, physics subject, and I think our life it is physics, and because how I move it is physics. We have velocity, we have all of physics. How to say? I think without engineering we don't have a robot, we don't have plane, we don't have building,
Right.
and anything. It is important for our days nowadays.
Right. Very good. So what you are saying that you think engineering is the technology, the things that the humans have built for the improvement of their lives.
Yes, yes,
And they use maybe science like physics and chemistry and other things.
yes, yes.
Yes. Okay. Very good. What else do you think engineering is? Medina, want to try something?
I think engineering is.
I'm a bit old, so you need to speak.
I think engineering is something that the people need. The топливо. Ой. Нет. I think about alternative engineering. It's like that we can take energy, transport it from the air, from the earth, from the water, not only from the oil. And I think engineering is very expensive, necessary for living.
So you are saying that engineering is to look for alternative ways of doing the things that we are doing today.
Yes.
So finding alternative sources of materials and energy so that we could continue sustaining our life at the same standards that we are doing now.
Because oil resources is not бесконечность. It's not so much in our world.
Right, so the resources are finite, will end one day.
Yes.
So we need to look for other resources, and engineers are the ones who will help us
Yes.
look for alternative resources that we could sustain our lifestyle.
Yes.
Thank you very much. Very good. Any other definition? If someone asks you, you now studying if you say you are studying medicine, so what is medicine? You could tell them, medicine, providing health, whatever. If someone say you are studying engineering, so what is engineering? Anyone else would like to try to define it? You pass it to me here. Okay, pass it to. Okay, thanks.
The one who innovates easy ways to live.
So innovation is to innovate. Engineering is to innovate easy ways to live. What do you think? Easy ways to live. So there are people in finance and banking who also innovate easy ways for them to live easily.
No, but the thing is, like you have shown us our iPhone. This is an innovation that engineering has given to the world. Now everyone is using iPhone.
Right. Okay. So it's innovating some technological tools that makes life easier and better. Okay. Thank you very much. So this is actually not a trivial question. It's sometimes one of the difficult questions to define what is engineering, where does it start, and so on and so forth. And hence, I would like to give you this framework. I think you've heard of CDIO, right? It's on our door also: conceive, design, implement, operate. So I want to take you through this framework because this makes it easy for us to understand what do engineers do. So if you think of any man-made object, this bottle, this bag, this logo, this iPad, anything. I think we talked about this, but you be patient with me. Let's go through the process again. Where did it start? From a thought. Start as a thought or as an idea. But why the idea started? Because maybe there is a challenge, there is a need, there is a desire, someone wanted to do something. So that's the part where we talk about conceiving. So I have sort of given birth to this product. But the product is not born like this. It's born first like an idea, a thought. It's just like when the fetus starts, in the womb. It's just a project of a human being. It's just one cell that will become two cells and may continue or may stop growing. So these are the ideas, the thoughts that we keep on having in our minds. Now, not every idea will lead to a product. Not every idea is going to become something that people will use or a process that will alter the people's life. But everything starts with an idea. And that's the conceiving stage. So engineers do conceive products, processes, devices, furnitures, planes, computers, glasses, cameras, LCD projectors, softwares, apps, and so on, so forth. Now, after an idea is conceived, after a thought is born, it's just that. It's just an idea. Could be a great idea, but it's still an idea. An idea of having the next smartphone won't allow me to go with my hand into my head and give you an iPhone or a new smartphone. It doesn't work like that. So the process of bringing technological ideas into life is engineering. And it happens in this sequence. So it starts with the thought, and we call this conceive, and hence you have the C. Okay? So this is the conceiving part. So C, conceive. Now, after you have the idea, so let's say you have decided to make this paper bag, let's say. Now, you need to start saying how big it will be. What color will it be? What material you will make it out of? What is the weight that it can carry before it's destroyed? This is the part where most likely you will take a piece of paper, you start sketching, or you start sketching it on the computer, or sketching it on, so you say, my bag will be something like this. Yeah, maybe it has this. Yeah, and maybe I have this logo on it. No, I will make it maybe like this from the bottom, things like that. So this is the time where you start designing. And designing of a plastic bag could be relatively simple. You need few drawings to explain it, or a few sketches. But if you are designing an airplane, I don't think if you say you draw this and you give it to the manufacturer will give you a plane. You need to decide how big, what kind of engine you will be using, what kind of material. So the drawings to design this could be literally 10,000 pages of drawings and specifications, but still it's the same thing. Someone has to think first of having a new plane, or a new paper bag, or a new mobile phone. So it starts with a thought. Then that person needs to either sketch it, draw it, design it, decide on what is going to be the design like. So if I take, can I take your iPad? Yeah. So when they come up with the iPad, in the beginning it was a thought, right? What do you think the thought looked like? What was the idea that Apple had? So Apple had the iPhone, the iPod, the Macs, and all these things, and then they decided to come up with the iPad. So what do you think the thought was? The guy who thought of it, what did he have in his or her mind? That's the handphone. But now there is a new thing that doesn't exist yet. Doesn't exist. So it's just a thought. What was the thought? Can you describe the thought? Is the question clear? I just want to take you through the process of conceiving, designing, implementing, and operating.
Maybe he had a thought, something.
Okay, I'll repeat the question. This is a product, right? Now you are all using it. Now, when was this released? Long time ago, 1960, 1955, 72. Not that long, okay? Yes? Yes? 2000, 2001? 2005. So let's say 2005. So I actually don't remember the year, so let's say it's 2005. Okay? I don't think 2005. No, not even 8, not even 9. Yeah. So let's say 2010. Let's say 2010 for ease. Okay. Now, for this to be released in 2010, when was this an idea discussed in Apple? 10 years before. So maybe 2 years before. Let's say 1 year before. So in 2005, 2006, 7, this didn't exist. But someone in Apple thought of a new product. So what do you think he or she had in mind? That's the question. Yes. A tablet PC. Now, was there other tablet PCs back then? There were plenty. There were plenty of tablet PCs. There were plenty, a number of them. They just didn't pick up. And people were starting, HP has one. Yeah, they actually thought this is, okay, again, my offer stays. Those who don't see any value in the class, you can leave. We've recorded your attendance. Yeah, thank you very much. If you sit here, I anticipate that you pay attention to me. So there were other tablet PCs. They didn't really working well, didn't pick up. They're cool. People take them to meetings, but very few things you could do with them. So someone in Apple thought, maybe there is a need that I'll come up with a tablet PC that will be very different, that will have an Apple kind of feel and touch and experience. That's an idea. Now, that idea, you need to discuss it with people. People say, come on, who wants to buy this? It will never happen. Some people say, oh, this I think is a great thing, but it's still a thought. It's still an idea. Now, let's say finally Apple said, okay, you go and design me this device. We don't know what we are going to call it, but let's say we have this device, and it's going to be you, Sugdish, Alex, Hans, Venosha. Okay, so this is going to be the team. Now, you need to take the thought into a design. So what do you think they have to decide on? Price. Okay, so price. How much will that be? So let's say roughly 1,005 ringgit. Okay, so let's decide on the price. Yes, what else do you need to decide on? Size, shape. So will this be that big or that big? So size, yes. What else? Weight. What did you say? Weight? Weight. Okay, so that is weight. What else? Shape. What else? Color. What else? Specification meaning? Huh? Apps. You straight away talk about the app. Let's talk about the hardware platform. Yes. Material. Yes. So what else? Camera. The first iPad didn't have a camera though. Yes? What else? So do you mean the weight? Yeah. What else? Reliability meaning? Durability meaning? Long lasting. Capabilities meaning? Okay, so this is okay. So what can be done with it? Okay. So for example, it's a choice, right? We cannot make this as a phone. Samsung does a tablet that is a phone, but Apple thus far say no, this is not a phone. You want a phone, you buy an iPhone, right? Battery. Weight, size. Okay, now let us stop here. Let me pick this one, which is the material. What are the materials available for the design team to choose from? So it could be plastic, aluminum, steel, wood. There are actually plenty of materials. If you think about it, there are plenty of materials. Now, can we make this out of wood? Why not? You see, this is a limitation that you are imposing. If tomorrow they make a wooden iPad, you'll pay extra for it. Not all the wood, the wood you're engineers, you could process it, you could treat it, you could make it look really stylish, right? So there are materials that they could have chosen from. Now, colors. What was the color of the first iPad? Black. Now, that is a design decision. You decide that it's going to be all black. Okay? What else? So the shape. So the shape will look like this. So this is, now, what is this radius? This is a decision. What is this length? This is a design decision. Now, these are things. Oh, no, nothing happened. So these are things that the designers have decided. And then, could they made it slightly bigger? They could. Could they made it slightly smaller? Yes. But these are things that they built models after model. They see how will you handle it. They put it inside a bag until they are happy with this. So this is the design stage. And in the design stage, as you move on, as you build prototype, try them, test them, give them to people to play with them, you move on towards having eventually an engineering drawing that looks like this with all the specifications in. Now, you guys talked about only the appearance part. Now, if I were to break this and open it, you will have a lot of electronics inside. You don't need it anymore, right? Oh, you still need it. OK, sorry. Yeah. So there will be a lot of electronics inside. So for example, one of the decisions from an electronic and a computer point of view would be what? What processor it uses, right? So the processor. Now, this is also linked to what it can do. So the processor capabilities, and this is an iterative process. We keep on thinking about it, discussing, changing it, showing it to the management, showing it to people to play with it until we are extremely happy. And all this time, did you know that Apple was actually planning this? No, no one knows. It's all in total secrecy until they decided that this is going to be that. No one said anything about the name. You guys just take it for granted it's called iPad, right? But do you think they have maybe contemplated a number of names before they choose the iPad? Yes. Definitely, definitely. Actually, there was this thought, you know, to call this a pad. You know, this has all sorts of connotations, you know, being a pad. Yeah, but eventually it was called the iPad, and the rest is history. Now, Apple has managed to do this, so now everything is done, everything is documented. We have the drawing. We have all the sketches, all the specifications. The design is done. So it started as a thought, conceived by someone, group of people, Apple founder, I'm not very sure, but it has to start as a thought somewhere. Now, this thought, I'm sure, has been discussed for, don't worry, I won't break it. So this thought was discussed between that person until the company approved that this is something that they are going to work on, and eventually they assemble a team to start the design process. Now, when they designed it, they made models. They made model out of wood and gypsum, and until they were very happy with the way it looked like from inside, outside. How did it look like? You know, even things like what is this distance, and this to obey Apple kind of philosophy. Only one button. Okay, so this is done. So we have designed it. Now, after you designed this, so now you have with you so that you don't worry. So we conceived it, we've designed it. Now we need to do what? Don't just use the word that I put you. You need to make it, right? You need to make it. Now there is a reason why CDIO used implement rather than make or manufacture, because this system, actually, the framework, works for anything, even if you are building a software. So because when you do a software, you don't really manufacture it per se, you implement it. So the framework uses I for implement because it's anything that now you are implementing, you are bringing it to life. So how did they implement it? How did they manufacture it? How did Apple manufacture the iPad? So it was conceived. Now we have it as a design. The design means I know every integrated circuit and processor and wire and cable inside. I know exactly how would the touch screen work, what kind of technology it will use. I know all the materials, all the sizes, all the weight, all the battery. I know everything about it. But it's still on paper. I still don't have the product yet. So I need to now manufacture it or make it. So how did Apple do that? Assembling materials. So how did they do that? They had, yes? So Apple has a CNC machine and put the pieces in. Okay. Look at the back of your iPad and see what's written. Can you read for me what is written there? Anyone can read this for us, please? Yeah. Yeah. Can you read it into the? Okay. Okay. Can you read for us, please? Listen. Yes.
Designed by Apple in California, assembled in China.
Right. So it's designed by Apple in California and assembled in China. So what did Apple do? Apple went to China. So now you go to China and find a manufacturer who has all these machines to make it, because Apple doesn't have its own machines. Apple can conceive, can design, and can give it to someone else to implement. Okay? So what did Apple do? They went to China, then they found a manufacturer who has all this assembly kind of capabilities, and gave them a contract to make them that number of iPads. Okay. Now, during manufacturing or assembling or implementing, what are the, because here sounds like a very exciting stage. What happens during the implementation stage or during the manufacturing stage? Do we just go travel to China, see this guy, say, okay, this is the drawing, make me the iPad, okay? I come and see you in 6 months. I want 10,000 iPads a month or 100,000 iPads a month. Do they do that, or how do they do it? Yes? So we talk about the manufacturer to decide how much does it cost. So we need to negotiate with them so they give us a good price. Okay, what else? Yes?
The parts for the iPad,
Yes.
the screen and the
Yes.
back cover and all.
Yeah, so you are talking about the whole supply chain of this iPad. How will it come together? Now, do you recall some time ago, Apple in China was having some issues with their manufacturing facilities there? Do you recall that? So what has happened? The workers in these factories that assemble the iPad and the iPhone were fallen sick. And they were blaming some of the material used in the touch screen for that. And they are blaming that Apple and the manufacturers didn't really take good care of the workers over there. So these are all implementations issue. The time when you have designed it, now you need other people to make it for you. You need to make sure that they have the machinery, they have the skills, they have the materials, they give you a good price, they continue keeping the right quality and things like that. It becomes a very important and essential essential thing. So this is conceiving and designing and eventually implementing. So let's say now we have done conceiving, designing, implementing. Now I have 500,000 iPads all packaged nicely. So am I done? So what do I need to do now? So, but the programs maybe was done at the simultaneously, right? So that I have the programs, I put the software in, am I done? So I have it, it has the software, it has everything in. Am I done? What else do I need to do?
Testing.
I need what?
Testing.
Huh?
Test.
I need to test it. So I tested. Am I done? Yes? Now I need to sell it. So I need to ship it. Now, when we buy this, where did this come from?
China.
It came from China. It doesn't come from, even if you buy in the US, it's shipped from China. So who ships that? A Chinaman. He said a Chinaman will ship it. So who will make sure that you receive it at your address after you make a purchase? So the logistic yes, what did you say? The postman. So it's the logistic, right? It could be FedEx or UPS or one of these courier kind of services. Now you've got it, and who received an iPad that wasn't able to connect to the internet? Was you, right? So he opened the iPad and he come and say the iPad doesn't work. It's a free iPad, you know. How come you come back to? Anyway, we took it. So what did we do with it? We sent it back to the supplier. So the supplier didn't say no, I don't have to do anything with this. They take it for testing. So there is an after sales kind of service. So you have to market it, you have to sell it, you have to ship it, you have to be able to, if someone have an issue with it, they call you, you need to be able to advise them. If they think that we just open it from the box and you cannot connect it to the internet, you have to be able to, to send it somewhere to be tested. And this cannot be you send it back to China because it's going to be very costly. So you have your test, you have your shop, you have your service center, and so on and so forth. This is all our operational issues. This is how you operate. Now, whether you are making a car, you are making an airplane, you are making an iPad, an iPhone, even your glasses, you could buy it and then something breaks, and then you go to the shop, they have to fix it for you. So these are all operational issues. Nowadays, the operational issue. So let me ask you a question. When this iPad is no longer in use, in few years from today, there is even better devices, quicker devices, and this, you cannot use it for anything. What will happen to it? Let me ask you a simpler question. Who have purchased 4 phones thus far? 4 phones. Raise your hand. 4. 4 or more. 4 or more, 1. 3 or more, 2. Okay, 3 or more. 2 or more. Okay, 1 or more. Yeah. So everyone. Okay. Now, for those who have changed the phone 3 times, what happened to the first phone? It's in the room, right? But you're not using it. Now, these electronics, what happened? Is in your room, not in her room, right? In the toilet. Toilet phone. Or is it in the toilet bowl? You ate it? Oh, you dropped it. You dropped it in the toilet bowl. Okay. Okay. So please listen. Yeah. So So the phones that are in your rooms are not being used. These are, these are called e-waste, electronic waste. All the old computer that you are not using. I'm sure if I ask you an old printer that you are not using, these are all called e-waste. And the companies now are under pressure to actually provide what we call afterlife kind of operational procedure. So when this is no longer in use, how can we recycle these items so that we put it back into use? Because I'm sure so many of us have, at home I have so many chargers. I don't know this is for what actually. I have my old cameras that I don't even use anymore. I have a VCR that, you know what's a VCR? Yeah. So this is like where you have the tape you used to, watch all these things are, we don't use them anymore. And now engineering and engineers are pushed to think not only of how cool this product is and how people will use it, but when people don't use it, when its life ends, what is going to happen to it? How can we dispose of it in a safe manner that does not impact the environment negatively? So hence the conceive, design, implement, and operate framework. Do you have any question? Okay, if you don't have any question, I'll give you 3-minute break, and then we can come back and continue. There's a question back there. Yeah. You raise your hand so that she gives you the mic so you can ask me the question that you wanted to ask. Guys, please settle in. There is a question. I think it's an important question. Okay. Please listen. Yes, go ahead. Yes, thank you.
Okay, what is implement actually?
We cannot hear you. Can you speak?
Implement actually.
What is implement? And you just also asked me, what's the difference between operate and implement, right?
Yeah.
Okay. So the question is, what is implement and what is the difference between implement and operate? So when you have the drawing, the design, if you can move here. When you have the design, it's just on paper. So you design the iPad, it's still on paper. It's not just an idea anymore. There is actually a detailed plan on how to make it and how would it look like when it's done. But it's yet to come to life. Okay? Then, when you make it, that's the implementation. So, to implement is to make. And implement, if you are making a physical thing, this is normally called manufacturing it. If you are implementing a code, a program, we say you are programming it. If you are implementing an app, you are developing it or writing the code for it. Okay? Now, what is operate? And you had a question about what's the difference between implement and operate. Now, let's say I made an aeroplane. So I thought of an aeroplane. I designed an aeroplane, and Airbus delivered an aeroplane. So now, AirAsia have purchased the A380 from Airbus. Now, for AirAsia to safely, effectively, and efficiently operate the Airbus, what do they need? They need maintenance, they need testing, they need all this kind of training. This is the part that we say operate. Now you make a phone. So there's a thought, there's the design, then you implement it. I have a phone. So I have a phone. Now, can I just use it? You think about it. So let's say I go to the North Pole and I want to call you. Will I be able to call you? Why? No service, no signal. Why? So that's the operational part. So operation, it's not only the phone. It's all the receivers, the thing that will take the signals from my phone, send it to your phone, and all these kind of things. Not only that, if it doesn't work in the North Pole, what is the nearest service center to go to? Alaska, right? So that's these are the things that we need to think of when you are making something as an engineer. So as an engineer, you don't just say, I had an idea, I am an engineer, or I made this, I am an engineer. You really need to think of conceiving, designing, implementing, and operating. C, D, I, O. Now, if the product is simple, like this, you could literally conceive it, design it, implement it, and operate it. But if the product is as complex as an aeroplane, there's no way you are the person who thought of it and designed it, you are the one who made it, and you are the one who is operating it. So let's say for an aeroplane, for example, what do we have? We have design engineers. They work for Airbus. And we also have manufacturing engineers who also work for Airbus to make the airplane. But often those who design and those who make are different because different skills. There are a lot of things they need to know. Now, the engineers that work for the airline, they work for MAS, British Airways, AirAsia. They also have their own operational maintenance engineers who test the plane before it flies, make sure that they change the part every, I don't know how many miles of flight and things like that. So you as an engineer, if I take a complex system like an aeroplane, you could be a design engineer making the aeroplane. You could be an implementation, a manufacturing engineer who make the aeroplane. Or you could be an operational engineer, a maintenance engineer who will be making sure that the aeroplane operates safely and follow the rules and regulations of the manufacturer. Is it clear now? So you could conceive, you could design, you could implement, you could operate. So now, if people ask you, so what do engineers do? You say engineers conceive, design, implement, and operate products and systems that hopefully improves the quality of life of people. And this system could be as simple as a bottle, or bottle is not that simple to make, to be very honest with you. A paper bag, or could be as complex as the space shuttle. But there is engineering in each and every, at each and every level of the CDIO process. Any other questions still from the rest? So that's CDIO. It's an extremely important thing, and I want you to know it. Now, the CDIO is a name of an initiative that was started by MIT, and Taylor School of Engineering is the only school in the country that's a member of the CDIO initiative. Now, your program is designed based on the CDIO initiative. So the foundation in engineering that you are studying is designed based on the CDIO. And because the CDIO is actually planned for the degree level, your foundation program is the first program in the world that is designed based on the CDIO initiative. Okay? Now, have you seen the word CDIO somewhere in the campus besides our door? Yeah. So from the 30th of October to the 1st of November, we are hosting the International CDIO meeting. So we will be having people from the United States, Europe, Australia, China, Vietnam, Japan, India, from all over the world to come here and meet and talk about CDIO. And there will be people who are coming here to learn about CDIO. How can we, through CDIO, get foundation students to build a robot, control it using their iPad, for example? That's really what you guys are doing, are conceiving, designing, implementing, and operating. That's what you are doing with your robot. So it's conceive, design, implement, operate. Now, during these 3 days, I'm stopping the classes so that all the staff and the students can attend the various talks and lectures and workshops that will be available. So I would like you all to please be here. Those of you who would like to volunteer to help us with the fall meeting, please let us know so that we can, you could interact with the international people. We do have people from Russia as well. So Madia and Medina could help them with the translation or show them where they can buy horse meat or whatever. Okay? So this is CDIO. This is extremely important. You need to know it. This is something that you need to know it. And if you think about it, it actually makes it easier for you to explain what do you do or what do you plan to do or what can you do as an engineer. So that's CDIO. Now I will go, I'll go for the CDIO one by one and link them to what we have been doing with the emotional intelligence. So to conceive, it's about thinking skills. It's about brain rewiring. It's about understanding how our brain works. Is about understanding the old brain and the middle brain. So this is the part where I'm spending so much time with you and repeating it again and again, the importance of how we think, the importance of the frame of mind that we keep for conceiving. Because for you to be able to conceive a new product, an original product, you need to develop your thinking skills, your thinking capabilities, because this is really the point of inception where something new, something that has never been before, you are thinking of it. And engineering is when you take that thought, that idea, through the designing, then the implementing, and hopefully eventually the operating stages of the model. Design. So when we design, we often need to think of something to be viable. And that's why when we talked about the iPad, you guys picked the price very quickly. You say, we need to design the price. And you are right. There's no way or no point designing an iPad that costs $1 million ringgit. No one will buy it. Even I think 5,000 ringgit will be like very expensive for anyone to buy. So you have to decide, although you could maybe put so many much more features and make it lighter and nicer, but it will become beyond the reach of so many people. So it has to be, part of a sustainable business model in the sense that people will be willing to purchase it. So this is one of the first things that you need to think of when you design. You have to make sure it's feasible. And feasible from a technological point of view, you need to, so for example, one of the issues with iPads, smartphones in general is the battery life. So how long does the Samsung or the iPhone battery last? Not that long. Yeah, so if you use it for games or surfing the net, maybe 1 or 2 hours. So this is actually one of the limitations of the battery. Now, if I go, yes, I can see you are a very unhappy customer, but it's okay. So if I go and I'm designing a new iPad or a new phone, and I simply say I want a battery that lasts for 100 years without needing to charge, you need to think, is this, from a technological point of view, is the technology available or not? So you cannot simply pick something where the technology not even available, not even on the horizon, and then you design it in. That battery that can last for a year could be in the research level. But when you are designing, you need to see what technology exists or about to be exist or is available in another industry that use it in. So these are the things that you need to consider when you are designing. So first, you need it to make sure it's, from an economical point of view, is viable. From a technological point of view, is feasible. So when you do your robot, we ask you to work within a certain budget. Don't exceed that budget. That's the economical aspect of the design. Now, when you started to say, I'll make the robot fly, I'll make the robot levitate, and so on, you need to see, is that technology available? And if it's available, is it within the technology, the economical limits that you are setting for yourself? So can you buy magnetic levitation for 75 ringgits, for example, or not? So these are the things that you need to balance when you are working on that. You need to ensure that what you want, what you are designing, is desirable. Meaning, people will like it. People will buy it. People would love to use it. And this is extremely important when you are designing things for other people. So it has to be not only things that are suitable for you, but suitable for others as well. So what does that invoke into you when I talk about you designing for others? What part of emotional intelligence you remember? Relation management. What else? I don't necessarily have a relationship with the... Do you have a relationship with the guy who made the iPad? Yes? Social awareness. Which part of social awareness? Empathy. So if I can... So for example, if I want to design products for pregnant ladies, how would I empathize with a pregnant lady? Want to say something? So I could understand that, yes, she's carrying, now movement is difficult, but how could I do it even better? How do I make sure that she's comfortable with the product? Yeah, she'll give you the, yeah, you think.
Safe materials so that it doesn't
I use
harm.
safe materials, yes, but specifically, how do I feel? How is a pregnant lady feeling?
Interview them.
I can interview them, know more about that, and I could, you know, and this is actually a design technique. I could literally put some loads on me and carry it around and walk and sleep, and after a day with that load, I will know how does, it's beyond just, so there are sometimes ways that you could actually empathize with people through trying to go through what they are going through. Now, if people say, understand those who are less fortunate, design for those people who are maybe less fortunate than you, how do you do that? You go and live with her. Don't just interview them, you go and live with them. So 2 semesters ago, a group of my students was working on designing something for a wheelchair. So they came up with all sorts of like funky, beautiful ideas. So I requested one thing from them. I requested one of the guys to get a wheelchair. We do have a wheelchair in the lab. And use the wheelchair from the moment he goes down from the car until he goes back for the whole day. So you be on wheelchair, try to go to the class on wheelchair, try to go to the toilet on wheelchair, and they came back to me with entirely different sets of designs compared to what in the beginning thought that the challenges of a person with physical disability is facing. They came with very, very different things. It's about, how hot this seat is when, you sit on it for a very long time. How certain parts of the campus are not really accessible to a person with a disability and things like that. So you could empathize, you could make it desirable by understanding what other people need through watching them on a video, interviewing them and asking them, or even better, put yourself into their shoes. I'm going to tell you this story, which is a true story. General Motors in the United States, I think some 10, 15 years ago, they started selling pickup trucks, and the pickup trucks were they're targeting ladies as a new market segment that is not serviced by the pickup truck. Pickup truck normally are purchased by people who have construction business, but this is quite a very, very nicely designed pickup truck, and the ad campaign sells the truck as this is for a confident woman. This is a strong car for a woman who is, want to take care of her family and things like that. But the women were not buying the truck. So the company was intrigued. What's happening? We keep on spending so much money on the advertisement, but nothing is happening. So they appointed a lady as a chief designer, and they say, okay, can you fix, is there anything we could do to this product? So she looked at the team that designed that car, and 100% are men. So they thought they understood what the woman needs, and then they built the car accordingly. So on her first day, what did she do? She sized them up, and she came with a pair of high heel shoes and a handbag to everyone on the design team. And say, take off your shoes, put on these shoes. Take the handbag, go into this vehicle. So you could see this guy like struggling, and then this is a high car. Then they realize, oh, this bag, where to put the bag. And that led to some simple changes, but the car suddenly became suitable for the female customer. So if you want to market the product to pregnant lady, do you really know how do they feel? Not you think, you need to know how do they feel. If you want to sell this car to female, you need to know how do they feel. And I believe that the issue with the shoes is not solved yet in the cars in general, because I see women, when they drive, they actually use a different shoe, or sometimes they are barefoot, and they have the shoe in the boot sometimes, right? I mean, you could tell me if I'm wrong or right. So there is actually still an opportunity to design a better car that a woman can use, because if 50% of the market is for females, so how are we addressing their needs really? So this is about the thing being desirable, meeting the needs of the customer is interested in it. And empathy comes very, very strongly here. I cannot design you a comb if I don't have hair. I cannot design you a hair dye if I haven't tried it and I haven't been through the process myself. Now, the product needs to be safe. So safe can go from complicated, being as complicated as making the airplane safe, or making sure that the building won't collapse, to as simple as making sure that this won't break, or if it dropped, it won't just by one drop, it's going to be destroyed and be rendered and usable. So these are the 4 things that you need to think of when you are doing the design. So that we cover conceive, we cover design. I just want to talk very quickly about the concept of a factor of safety. Anyone has a pencil? An old pencil, not a mechanical pencil. Okay. Do you mind if I break it? Can I break it? Okay. So you see, if I look at this pencil, and let's say this is a column in a building. So how would this column collapse? It will collapse if I put enough load on it, it will crack. So I need to understand what is the load required to make it collapse. Now, if this is a beam, this is, if a member stands like this, we call it a column. If it's like that, we call it a beam. So let's say this is a part of a bridge. Okay? Then it's supported here, and there is a load here on top of it. So how do I know what kind of load will break it? So I could apply the load until it breaks. Okay? Now I could measure this load. It's okay, right? Okay, thank you. So I could measure this load that is this beam is required to support, and I put a beam. So let's say the beam needs to support 100-ton kind of load. But when I design, I need to design a beam that can support up to. So if the beam is expected to have 100-ton on it, so I design so that it is able to support 100-ton, 200-ton, 300-ton, 400-ton, maybe. Now if the load that's expected is 100-ton, and I use material that's able to support 400-ton, I have used a factor of safety of 4. So this is called factor of safety. Now, when you go into the lift, you see in the lift they say maximum 8% or 1,000 kg. The rope that the metal rope that pulls the lift can actually support 11 times the maximum weight of the lift. So this is a requirement. So when you do, from an engineering point of view, you see the design is not only what is this and how thick is that and what is the color. This is very important part of the design, but safety is also a very important part. Now, when I expect that the lift is to carry 1,000 kilogram, then I am requested by law as a design engineer for the lift to design it in such a way that it could take up to 11,000 kilograms. And that is what? That is engineering. How to ensure that the bridges that we walk on are safe. How to ensure that the aeroplanes that we fly in are safe. How to ensure that the lift is safe. And always engineers are obsessed with safety. And this is something I would like you to start thinking of right now. How does material fail? How does the parts that you build fail? And it's an extremely important component of the design that you don't only think of how will it work, but think how most likely it's going to fail and try to build it so that it does not fail. So that is really the core of engineering and engineering design, if you ask me. So these are the things that I would like you to start really thinking of. What is engineering? What is design? Design is not only form, is also content. And what are the things that I want to keep in mind when I design? The thing has to be desirable, has to look nice, has to be economical, the technology has to be available, so it's viable, feasible, it's it's safe, and it is so it's economically, technologically, as well as there is a desirable element to it, and it's safe to use, which is extremely important. I think I better stop here because you have class after this, right? Yeah, so I better let you go. Thank you very much, and hope to. So for tomorrow, please bring all the equipment with you. Bring the wires, because we are going to ask you about programming, and we're going to ask you about everything that you've learned. Thank you very much.